Hi class, I wanted to make a video about two of the problems on 4.3, number 15 and number 16. Okay, so number 15 says a graph of the population of yeast cells in a laboratory culture as a function of time from t equals 0 to 2 equals 18 is shown. And has a time in hours, and then it says the number of yeast cells. Okay, so we can see that, we can pretend this is the laboratory culture. We know that typically the cells will increase sort of exponentially, but then they sort of flatten out. Typically, doesn't tell us, but it's usually the shape of a logistic function where, again, it grows exponentially, but then it starts to flatten out. Okay, so it says describe how, also just to make a little note, this looks like it's concave up to start out with, and then it changes to be concave down. Because if you sort of imagined this function following the same curve, the same trajectory, it looks like it is like an upside smiley face rather, right? That's concave up. But maybe like around here, it looks like it sort of switches to be concave down. Okay, so that's just something I noticed right off the bat, and so we'll see if that comes up at some point here. Okay, so it says describe how the rate of the population increase varies. So the number of yeast cells is always going up, right? It's just that it looks like at first, like they're asking like, how is the slope changing? How is the rate of change changing? So if we had like the slopes of the tangent lines, we could kind of see what's happening here. Okay, these are very rough tangent lines, okay? But you can sort of see it starts out fairly flat, it starts increasing, and then it kind of levels off a bit, okay, when it reaches like the maximum capacity of the culture. So the options are the rate of increase of the population is consistently small, the rate of increase of the population is consistently large. No, I wouldn't say either of those because the rate of increase is not staying the same. Okay, the rate of increase is, again, really asking you the instantaneous rate of change. What's going on with the derivative, really? Okay, that would be how we're talking about the rate of the population. So I wouldn't say either of those first two. Then it says the rate of increase is initially very small, then gets larger until it reaches a maximum. I wouldn't really say the rate of increase is always getting larger. Okay, the number of yeast cells, like F of T, if we had that, yeah, that's getting bigger, but they're talking about the rate of change of those. Okay, so we're talking about, again, the slopes of the tangent line. So I wouldn't say that. Let's see what we've got in the last two choices. The rate of increase of the population is initially very small, then gets larger until it reaches a maximum at about T equals 8 hours, and then decreases towards 0 as the population begins to level off. Yes, that is the one I would go with. We can read the last one just to make sure, but the rate of increase of the population is initially very large. Not really. It starts out pretty small, then gets smaller until it reaches a minimum at about 8 hours, and then increases towards 0. No. Okay, so hopefully that makes sense of why I selected that. Again, if we're talking about the slope of the tangent lines at these points, these just made up points, it starts out pretty flat, like a slope of 0, and then it gets steeper, and then it starts decreasing again. Okay, then it says, at what point is the rate of the population increase the highest? So they're asking essentially where it looks like it is the steepest. And I would guess it looks to be the steepest around here. Now, how we're going to estimate that can be very challenging, especially in Webassign. It can be a little frustrating, okay, to try to figure out what they're exactly looking for, okay? I'm trying to zoom in, and I don't know if you guys have that ever happen. It takes you to another problem. Okay, so they want to know, again, where it looks like it's the steepest. And I would say it looks the steepest like somewhere here. Okay, because it's increasing, getting steeper and steeper, but then it starts changing and starts kind of flattening out if we were to think about those tangent lines. So this is where, though, it's not, and then because in the word problem, it says that it increases until at about t equals 8 hours. I think a lot of people be tempted to maybe say 8, but I think they actually are looking for like the point in between there, and that's not really at a whole number. I'd say maybe 8.5. Let's see if I can even zoom in a little farther. It's going to take me off my screen just to kind of see again where it's at. Oh, it didn't take me away. That's good. Okay, let's see. I think again, we're just kind of eyeballing where we think it looks like it's switching from concave up to concave down, because at concave up, what that's saying is concave up is saying my rate of change is increasing. Okay, my slope's getting steeper. Then when it reaches 0, it stops. Okay, and then it's going to start decreasing from there. So if I had to try to guess what this point is, it wouldn't be easy. I'd say it's like close to 9, but not quite 9, and maybe about, this is 340. So let's say, I said originally 8.5, but now that I zoomed in, let's go 8.6 and 340. Again, I know it can be frustrating because it's not at a whole number, and you might have seen this in other Webassign homework problems before. Let's keep taking a look. I submitted for testing just to kind of show you what they're looking for. I'm also kind of interested, like if I put 9, would they let me do that? I like to sometimes just see what are the limits that they have on Webassign for the accuracy. Like, is there a certain number? They also accepted 9. Okay, so I feel like it's like anywhere around there they would probably accept, but I don't think they're going to accept 8, which is a little tricky because it says here about 8 hours. So you would think that's where it was, what would be referring to. Okay, on what intervals is the population concave upward? So again, they don't refer to it here. They're just asking where it's the steepest, but that is what we're going to use to sort of base off of the fact that this is concave up, and then when it gets the steepest, that's when it starts going down. That's where the concavity switches. So I would say it is going to be concave up from 0 to that number, whatever you use. If you use 9, use 8.6, whatever it is, you just would want to probably go with that one. Okay, so let's go ahead and say 0 to 9, since that is the one that we technically have here. And then for concave down, it's going to be concave down from then on. Okay, so let's go ahead and say 9 to, now here it just says, I feel like it could also be a little confusing because it says that this is the graph from t equals 0 to t equals 18. So I'm assuming we're stopping at 18, but it's not really totally clear. So I'm going to say 9 to 18, and then the coordinates of the inflection point, again, that's going to be the same coordinates from whatever we typed in for B, from where it went from the steepest and started getting less steep. Okay, so hopefully that kind of makes sense a little bit there. B and D are really asking you the same question 2 different ways. And there are some variations in what Webassign will accept for B. Okay, let's go and take a look at 16. So I know it says X everywhere because we haven't really gotten to it yet. When I had to sit mine for testing for the whole thing for whatever reason. I think you guys had the option to do it per problem, but anyways. 16 says, let F of t be the temperature at time t where you live, and suppose that t equals 2. At time t equals 2, you feel uncomfortably hot. What happens to the temperature in each case? Okay, so let's see here. This is saying that the change in the temperature at t equals 2 is going down. Okay, so at t equals 2, you're very hot, but thinking about like the instantaneous rate of change at 2, it's -3. So it's decreasing. Okay. but also the second derivative is -3. So not only is the slope negative, but the slope of the slope, if you think about it that way, is also negative. So let's see what these questions say. It says the temperature is increasing. No. The temperature is decreasing, but the rate of change is increasing. No. The temperature is decreasing and the rate of change is decreasing, becoming more negative. So sometimes I like to think about, because when we first learned about this, we were referring to how particles were speeding up or slowing down, and the particle would be speeding up if the slope and the second derivative, the acceleration, were working together versus them working up in conflict with each other. So here they're working together, okay? The temperature is essentially speeding up in a negative direction, okay? The temperature is going down and the rate of change is also bringing it down fast, okay? Let's take a look at the next scenario. It says here, the temperature is, the rate of change of the temperature is positive and the second derivative is also positive. So here, the temperature is increasing and the rate of change is also increasing. Not good, because it says you feel uncomfortably hot. This would be the worst case scenario. Okay, let's take a look. The next one. The next option is that the rate of change of the temperature is increasing, but overall, the like the slope of the slope is negative. So what that means is they're kind of working in conflict with each other. So the rate of change is increasing, but the rate of increase is decreasing. Okay, so they're working against each other. The temperature should be coming, eventually will be reaching 0 and then coming down. Okay, so we haven't reached like the maximum yet here at 2 for this scenario, but eventually it'll start coming down. Versus this scenario where it says the rate of change of the temperature is going down, but the concavity is up. So what that is saying is that it's decreasing, but the rate of change is increasing. So the temperature is going down, but probably is going to start coming back up if we can get, if the rate of change is getting is increasing. Okay, so I know that is can be a little bit challenging as well, just to sort of break all those down. So they're talking about, first of all, how the temperature is increasing, decreasing, but then they're talking about the rate of change of the increase or decrease. So again, the first time we see all of that is with velocity and acceleration. And I still think that those can really help just to kind of conceptualize the different things going on. All right, I hope this was helpful. I will talk to you soon. Thanks.